This is a demonstration of the 3D plot, and here we have the legend. And black circle open is 100% mutant, while a completely orange bead is wild type. And then you have all the fractions in 5% increments going from 595 to all the way over to 100. These are about 25,000 micron laser dissection cuts, which has been performed in 3D in various tissues. This figure, this 3D graph, illustrates the mitochondrial mutation, the same one analyzed in all these laser capture cuts. If you follow the link, you can rotate yourself. If you noticed here, we have 2 homoplasmic mutations at these sites, while the rest of the tumor is more or less 50-50. We have some spots that are only wild type, homoplastic wild type, so we know we're tracking a cell line having this mutation. This is from a primary breast tumor. We are lucky enough to have the lymph node operated from the same patient, and we have performed the same experiment. As you can see, we can track the same mutation to a lymph node, and we can rotate it around, and we can have a visualization of it. In this tissue, I don't believe we have any pure homoplasmic mutations, or we have a few pure homoplastic wild type. That could be infiltrating lymphocytes, there could be normal cell growth into the tumor mass in the lymph node. Remember, this is the lymph node from the same primary patient with the breast cancer. And the third tissue in this series is a liver metastasis from the same patient as the breast cancer. Here we go, and here is how a metastasis would look like. As we can see, there is actually more non-mutated areas in this tissue. We have one example where we probably have a 5% wild type and a 95% mutant, almost homoplasmic. But again, it's scattered around. So what does it look if we compare the wild type fraction from all these beads in this plot, the previous and the previous plot there again? That would look something like this. The primary tumor is the black, and it has this distribution where most of the sampling, our laser capture samples, has a wild type fraction around 60%. While in the lymph node, there is more wild type. No, there is less wild type fraction. Actually, that means there is more mutant. While in the liver metastasis, there's a higher percentage of wild type fraction. To get to the tumor stack, one have to follow this link that takes you to a YouTube video where you can go through and see where it's placed the grids. Unfortunately, in this video, some of it's flipped, and I have to correct that. For the lymph node, we get the stack in YouTube as well, just to get an impression on how, let's see, lymph node stack here. And this is, here we're cutting one cut, put it on a membrane. Then the next 5 cuts are put on glass slides, and the 6th cut is put on a membrane, and we have done laser capture, as you can see. Here we go, 11, and then we should come down to 16 and 16 with the cuts, like this. The microscope is scanning and taking all these pictures and stitching it together. Unfortunately, that affects, we get some effect here that you can see that it is not a perfect circle, but if you look at it in a microscope, these circles will be round. So this is an artifact created by the software of the microscope, stitching together the pictures. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, 7 pictures that are stitched together in the microscope. Here is just the illustration of the CTC analysis. All samples are run towards an internal standard, which has the 2 variants and the heteroduplexes out here. And then we're calling the peak height. For this one, we have only the mutant variant. And in this case, here we have a peak height relationship at 30-70. And here is the opposite, 70-30 and 90-10. You see that we lost the homoduplex for this one. And here we're at 100%. There is no trace of the heteroduplexes.